let's start with it. So no need to write anything right now. I'll give you time to copy both of you. Among the seven fundamental quantities, you have the first quantity as mass. So it will be represented with the help of capital M and brackets will be put like this. Remember the SI unit and CGS unit properly. For few quantities, definitely remember them. I'll tell you what all things you should memorize and what all things you can skip, which will be done. See, some things are there that cannot be done right now. It's just the starting. See, SI unit for mass is kg and CGS unit is gram. Now, what is this CGS? SI, I told you that it's the standard unit. Similarly, what happens? CGS unit is a unit just chosen below SI unit. So, from the term CGS, C means centimeter, G means gram, and S is second. So, this will show that, okay, one standard is set, SI is set for every quantity, but we should have a little less designated, but we should have one more quantity standard system. So that is why the need for CGS quantities was chosen. So CGS unit basically means SI units convertible form. You can always convert SI units into the CGS unit. So with time you will be very familiar. Second concept that you have, first was mass, second is length. So length is represented as capital M. Iqra, is it audible to you too? Your internet is fine?
Yes, ma'am.
Okay. So length is L. See, you have to open the camera. If the internet is working fine, please try to open the camera, have an arrangement. So see, when we're talking about the length you already know. It's the distance actually. It's like the measurement. Length term you know. And it's a fundamental quantity. SI unit of length is meters. And CGS by the name suggests it is centimeter. See, this is easy, but you need to remember mass, length, and time. Your MLT will construct your dimensional formula. Time is very easy. Dimensional formula is written as capital. What I'm writing in the brackets is the dimensional formula as representation. When we'll do the dimensional formula, that time I'll be writing it straight away. SI unit is very easy because both are same. You don't need to write hours, minutes, or something. Both are same. So just write it as second. Then we have temperature. So what is temperature? Temperature part, the portion of temperature will come in your class 11 second book. In second half, you have temperature related topics. I told you in your first class also. So see, in some books, you will find temperature represented by theta. And in some books, you will find temperature is represented by Kelvin. So this capital K. So both are valid. Sometimes why K is mentioned because the SI unit of temperature is Kelvin, which is represented by K. 453 Kelvin, 300 Kelvin, 273 Kelvin, like this you will see. And some of the units, you will find it in CGS. When you see this degree Celsius, the Celsius part is actually the CGS unit of temperature. So standard one is Kelvin. Celsius is different. So their conversions and all we'll see in the last chapters of thermal physics. But if a question comes where you see you are able to identify that yes, delta T is temperature in the formula, and you need to write the dimensional formula. You can use any of it. That is acceptable. Whatever is suitable to you. But I have given you both because when you will read and if you will see the books, different books, these two are mentioned. Then fifth is electric current. Electric current is used in some of the questions of your class 11. Very few questions because it's actually a portion of your 12th class. But very few questions are there from electric current. But if a question is there, it will give you the formula by itself because it's not a part of your class 11. So usually teachers try to avoid this electric current questions only, but you still have them. So it is represented not with the symbol C. Current is C, starts with C, so don't write it as C. It is represented by, because the SI unit of current is ampere. That's why this is represented as C. You don't need to remember it's SI unit. right now. Remember the SI units till the fourth one only. Fourth one is very easy. Till the fourth one, these are important to know. That's it. These, see, since you are studying the fundamental quantities, we'll be doing every quantity. But what is important, what is not important should also be there in your mind, because right now it's just the starting. But at the end of the session, you will have both the books in front of you, which you have to just revise in your study leave. Right? So just have important things in mind, and during the revision time, just go through them. Luminous intensity basically means like this tube light is switched on right now. So what's the intensity of this light? It's very intense, very bright light, low dim light. So that is luminous intensity. Its unit is candela. Again, I'm saying no need to remember this also. Amount of substance you will do in your chemistry. The first chapter of chemistry, molar concept. Mole concept is there. There you will see all the number of molecules, your number of moles and everything. Amount of substance. So this is given by moles. Means MOL is written for its demonstration in the units. So these three SI units, have it in mind if you encounter it anywhere. Rest of it, both SI and CGS, you should remember. So these are your 7 fundamental quantities that are basic in nature. They cannot be constructed by the help of different quantities. Indeed, they help in forming new quantities. Now, I told you that in SI system, 2 supplementary quantities are also present. Means these are the main, but 2 additional quantities are also there. That we'll see later. First, you make it in the tabular form. Just make it in a tabular form so that you remember. So we'll be doing the 2 supplementary here. And what you both can do, keep on texting me done. When you all have completed, I'll just scroll the screen and I'll tell you. No problem. Okay, let's move forward. Now both of you have already completed. The two supplementary quantities are also, they are very easy. The two supplementary quantities are already very easy. See, when we say supplementary, it means, see, it's something additional to what is your listed value, right? You are already familiar with one of them. That is angle, the plane angle. These are the supplementary quantities, plane angle. So what is meant by plane angle? Plane angle means nothing. You are drawing two lines on the sheet in two dimensions, right? On your two-dimensional sheet, on a sheet of paper, you're subtending two lines and they are intersecting at an angle, that is theta. This is what is your plane angle. That's it. You already are aware of it. But why are we studying it here? One, that it's a part of supplementary quantity. Second, you don't know its unit. What's the SI unit of angle? Can anyone tell? Anyone has any idea? Angle.
Radian.
Radian. Very good name. Yes, it's radian. Correct. It is radian represented by RAD. And how is plane angle represented? Theta you have been using in your 10th class, sine theta, cos theta, you will be using. Now, when it comes to solid angle, it means the angle in three dimensions. Like, think of a cone. If you have a cone, the end part of a cone, like this is your cone. If I just take this part of the cone, just this part, what is this? This is actually a three-dimensional angle of the cone because it is not 2D, it is a 3D figure. So this is what is your solid angle. How do you represent it? It is represented by symbol omega. So we don't actually use this. This is called as omega, this symbol. We usually don't use solid angle in physics. You will hardly use this anywhere. And what's its SI unit? See, Neha, you told about radian. Just add three letters, STE. That is steradian. That is the SI. That's it. Now, before you write down this, let's just discuss the derived physical quantities and then now we'll directly jump onto the dimensional formula. This much introductory part is sufficient. Derived quantities we already saw. When you are using the fundamental quantities, you are putting mathematical operations in between them, you're forming new quantities. Best examples when you take like force, F is equal to ma, means you are multiplying two quantities and you're getting the new one. Or if I say velocity is distance divided by time. Velocity, I'm writing here as speed. Let me write speed because velocity you're not very much familiar till now. Acceleration is speed by time. So this is acceleration. So whenever you're forming a new quantity, those are your derived. So these are the basic terms that you will be using. Now we'll go on to the construction and actually your dimensional formula will begin. So this chapter has three parts in it. One is what you should know at the end of chapter. One is the dimensional formula writing. For any quantity dimensional formula, you should be able to write. Second, you will be able to derive quantities using dimensional formula only. And third is using the concept of dimensions, you can convert one system of units into another system. So first we'll focus on understanding and writing of dimension. Once that is done, the rest of the chapter will be very easy. Okay, write it till here. Is it clear, Neha, Iqra, till here?
Yes, ma'am.
Yes.
Oh, please write. Both of you have completed? Okay. Now let's start with the writing of dimension. See, remember, you have to write the dimensional formula on the basis of a skeleton structure, that is MLT, like this. Now, the powers of MLT will be something, and we'll be writing the dimensions like this. Means M will be representing the mass, L will be representing the length, and T will represent the time. Now look here. If I have the area, suppose I want to get the dimensional formula for area. Generally, the mathematical formula of area is length into breadth. Now, we have to write the dimensional formula from that table of fundamental quantities only. You can use any quantity, but you have to write it from there. You cannot make any new quantity and write. So length is already given in that table. So for length, I will write it as L. Can you tell me for breadth, out of that table, those 7 quantities, which one should nearly represent breadth?
L, length.
Length only. Yes, Iqra. Correct. So this will be length only. Now let's put it in the mathematical formula. So it will be L into L, that is L square. So now when you have to answer its dimensions, the dimensional formula will be, you can write it as L square also. This will also go well. But if you want to write the complete one, you can write, see, mass is not there. So m to the power 0, L is there, L to the power 2, time is not there, t to the power 0. This is how your dimensional formula is concerned. It's a very basic, very easy example. Now look class, in your class 11, the questions that will come will be from the portions you are already familiar with. Like your questions from fluids will there, your questions from gravitation will be there. Like these are chapters which are already present. But the problem is that right now you are not aware about all the entire chapters. You don't know any formula from any of the chapters. So right now we'll provide you with the formula. But at the end of session, when your final exam will come, that time do not expect that formulas will be given to you. If you see your school's previous year's paper of class 11th and the questions from dimension, they hardly give the formula. For some questions they will give, but for the basic questions they won't give. That is there and already there in your class 11. So right now, again I'm saying, when we'll be discussing quantities, you will not know the formula. So don't focus on the formula. What is your task right now? You should be able to create the dimensional formula perfectly. Writing on the dimensions is important to you. Why is this quantity present? What's the meaning of it? What's the formula for it? You have entire big chapters to deal. There you'll study every formula and you have to remember it. Right now, I am repeating this because many students want to learn everything in the first chapter. What's the meaning of this term, that term? As we'll see, as we'll be proceeding, you will by yourself only learn the different formula. Okay, next, volume. Volume is very easy. It's length into breadth into height. So all are dimensions of length only. See, you have to write everything from that table only. No derived quantity can be represented. So this is L and this is also L. So dimensional formula can be written as L cube, or you can write it as m to the power 0, L to the power 3, T to the power 0. Now, one more question. Let's discuss and write, then you can copy down this. Formula of density. Do you remember from your 9th, 10th? Density in science. It's mass by volume. This is mass by volume. So density's formula you should know. Density's formula will not be given in your class 11. This formula at least you should remember. Now, out of that list, for mass, we do have mass. So I think we can write mass as it is, m divided by. Volume, we don't have exactly from the list, but we know it is L cube. You can write it as L into L into L. So I'll write this as L cube. Now I have to write everything symmetrically in a line in the numerator. So when this L goes up, it will be m L to the power minus 3. Signs will change. When the power goes up or it comes down, means reciprocal occurs. Or you can write this as m L to the power minus 3 t to the power 0. When I'm writing nothing here, only m, it means m to the power 1 is there. Like here it means m to the power 1 is present. So this is the dimensional formula of density. Am I clear till here?
Yes.
No. Write it, then we'll see some quantities. See some of the physical quantities we have to see in your class 11's portion where we'll discuss it. Please write it first. Okay. Let's move forward. Now, see, class, we'll be doing some quantities first, like this. The way I've given you examples, those are there in your syllabus. Again, I'm saying it. Don't focus on the formula. Don't focus on what is the meaning of this, even if you're not understanding the meaning right now. Like what is torque, what is Young's modulus of elasticity, like these. You see the formula. From the formula, try to write down the dimension. That is your work. Now, few things you should remember also, that I'll tell you. So it's better if you draw it in tabular form, serial number, quantity, formula, and all like this. So we'll go one by one, and then I'll give you time to write down all these things. Displacement, forget. Distance basically means the path covered, length that is taken. So dimensional formula is of length only. I'll tell you one thing. We'll do this table in two parts. This is the first part. Then we'll do some calculations, questions, numericals we'll do. Then we'll complete the table in the second part. Why I did this? Because the first part is very important and you should memorize few things from the first part. Second part is this formula. So see, from here, SI unit. What is the SI unit of length? What should I write?
Meter.
Meter. Okay. This is meter. This is centimeter. Now, when we come to speed or velocity, speed is basically distance by time. Whenever distance changes with respect to time. And when you talk about displacement, then we don't use the term speed. We use velocity. So it's like speed only. So dimensions will be same. So distance is L. Time is T. So the final formula will be m to the power 0, L to the power 1. But T will, when it will go up, it will be T to the power minus 1. Now, SI unit, this is meter divided by time. Length by time. So meter divided by time is second, meter per second, or centimeter per second. Seconds will be the same. Now, Neha, you tell me, if I'm talking about a third quantity, which is acceleration, which is velocity by time, what should I write here instead of velocity?
L LT minus 1, you can
LT to the power minus
divide it by T.
divided by T. So what will I get now? Finally,
LT minus 2.
yes, LT to the power minus 2. Perfect. Yeah, very good. So see, SI unit is very simple, meter per second square, because one more time is now getting divided. And this is centimeter per second square. Okay. Then we have momentum. Iqra, can you try? Momentum is mass into velocity. See, momentum is basically the amount of motion that is present in a body. Like if you are there running, okay, and you try to stop, will you just immediately stop? You will slow your speed and you can stop. If you immediately try to stop, or if you try to jump out of a moving bus, because of the momentum, we tend to walk also. Right, so that is momentum when amount of motion is still left. So this is the formula. Yes, Iqra. What should I write first?
M
M multiplied to
LT.
LT. Look,
No, multiplied by M.
what
Sorry,
is
M
C?
LT by T, I think.
M by T, L by T is velocity. Final formula is LT to the power minus 1. No, this is velocity. Okay, so you are just multiplying M to velocity. Velocity is LT to the power minus 1. So when you will multiply these two, it will be MLT to the power minus 1. For momentum, the mass SI unit is kg, speed is meter per second. So it becomes kg meter per second, and this will be gram centimeter per second. Now one thing, out of these, leave momentum for remembering, but distance you will remember, which is length. Speed and acceleration should be memorized by you. Few things, remember just few things, 5 four to five things are there that will just help you quickly answer things. Okay, you start making that table till here, then we'll discuss some more. First, do it till here, and if you have any doubts in between, you can ask. Okay. See the next few quantities. Force is very important, class. Please remember force. Force and work done, these two. So 5 quantities, I think now you have this to memorize. Force, work done, acceleration, speed, and of course distance. Distance you will remember, distance is this length, so it won't be difficult. This velocity, acceleration, force, and work done. Why work done? I'll tell you why work done. Rest of it you can avoid. You will remember it through the chapters, and right now the formula will be given. See, forces, if you remember your class 9, you did Newton's laws of motion. There a formula was F is equal to ma. Can you recall? F is equal to ma, right? See, m is mass. Now you people have written the formula of acceleration, dimensional formula. Iqra, can you read? What's the dimensional formula of acceleration?
LT minus.
Correct. LT to the power minus 2. So it is m multiplied to LT to the power minus. So formula will be mLT to the power minus 2. Now, unit is also very important for force. It is Newton. This CGS unit is dyne, dy in dyne. Then work done. Now, why am I focusing so much on work done? You need to remember work done also. Class, whatever is the dimensional formula of work done is exactly the same dimensional formula for all kinds of energies that are there. Internal energy, kinetic energy, potential energy, any sort of energy has the same dimensional formula. So by remembering one, you will remember all the energy. That's why I'm saying work done also remember. So this is force into displacement. Now this is force, mLT to the power minus 2. Displacement means the length. So it's just that one component of length will be multiplied. ml square t to the power minus 2. Now energies also have the same unit. Work done has the same unit as of joules. It is joules. Okay, represented by capital J. And CGS unit is earth. So for all the energies, this is there. Pressure is there. Pressure is also important. But see, whatever I have marked, whichever, those try to remember them. Pressure is force by area. So see, force is this mLT to the power minus 2 divided by area is L square. See, how will we write this? M is there. Now look at L. When this L will go up, the power will be minus 2. This is 1 right now. That time it will be, this will become minus 2. 1 minus 2 is minus 1. This is how you will write the power. T to the power minus 2. This is the dimension formula. Unit will be Newton per meter square. CGS unit will be dyne per centimeter square. I've just made this note point so that you remember that work done and types of energies have the same dimensional formulas. Okay, then we have certain sets of questions so that from these only, then we'll complete the table later on. So please write down this part first.